Kaushik is not attending, sir.
Okay, first we'll discuss about the homework sum. So now what is the homework sum? Anybody can tell? So I have given the question that you can see, observe very carefully. Two bodies having masses in their ratio. How the masses in the ratio, guys? Mass ratios they have given. Let me take M1 and here M2. Two bodies I have given. Their mass ratios is what, Hari? 3:4. Is it yes or no? That is what we can take. So now they're asking, when a force is applied in the first body, it moves with the acceleration of how much? Let me take now two bodies. This is body 1 and this is what? Body 2. Now, first body I applied a force. Force is equal to how much, guys? Some force I applied. It moves with the acceleration of how much, guys? 6 meter per second square. Yes or no? If force is applied, so it is moving with the acceleration of how much? 6 meter per second square. Now they are saying that how much acceleration will the same force produce in the other body, they are asking. So for example, see, so let me take, this is what first Harish. Now Harish, I applied some force. So he is producing an acceleration of how much, guys? He is having some mass M1. He is producing an acceleration of how much? How much acceleration? 6 meter per second square is producing. Now, I don't know how much force it is, but the same force if I applied on second body, let me take the second body is Gokul. Now, I am applying the same force I am applying, and this body mass is what? M2. We don't know that. Then what is the acceleration of this body, they are asking. Is it yes or no? Yes, everybody? Please respond. Now, here we know the mass and we know the acceleration. If we'll find the force, then here the same force is applied so that we can find the acceleration or not. Yes or no?
Yes, sir.
Yes, that is what you have to remember it. Now they have given in the question, observe very carefully. So let the force acting on the two bodies is F. We don't know that. We have to assume as a what? F actually. Okay. So now what is the mass ratio they have given? Two bodies, or what is the mass ratio they have given? What is the mass ratio?
M1.
What is the mass ratio they have given? Two bodies having a mass ratio of 3:4. Now, let me take the case 1. Okay. So, case 1, mass of the first body, M1 is equals to, case 1, mass of the first body, M1 is equals to, who will say? M1 is equals to how much? Case 1, mass of the first body, we don't know exactly, yes or no? M1 is equals to 3 times of m kg. Is it yes or no, Hari? We don't know the value. It is a ratio. That is why I'm assuming as a m. Any doubt? Please. Next, acceleration of the first body. How much acceleration given? Everyone?
6 meter per second.
Acceleration of the first body. So let me take A1. A1 is equals to how much, guys? 6 meter per second square. 6 meter per second square. Now, let me take the force applied is F1. Force applied is equals to F1. So now F1 is equals to what is the formula? You should tell me. I should not say. F1 is equals to M1 into A1. So M1 is equals to what? 3m into A is equals to 6. So which is equals to how much it is? 6 3s are 18m. Understanding? 18m. Okay, this is all force and kilogram meter per second square, which is equals to what? 18m newtons. Is it right or wrong? F1. Everyone? So this is what it is, case. So I am taking here ratio. It's not, 3 kg they have given. 3 kg given means directly you'll get 18. It's ratio. So that is why I'm taking as a m. Is it okay? Vatni, Mitakshri? That is what you have to remember. Okay, Ra? Now you observe. Let us go for body 2. This is case 1. Now case 2, tell me everybody, case 2, what will come? Case 2. What is the mass of the case 2 body? Mass of the second body, M2 is equals to, everyone. Mass of the second body, M2 is equals to how much? 4m. Understanding? 4m kg. So why I am taking 4m? Because they have given what? Ratio. Okay. Because Given ratio is 4. That is why I am taking 4m. Now, acceleration of a second body. We don't know. We have to find that. Acceleration of a second body. What I can assume? Acceleration of a second body. A2. Is it yes or no? Yeah, we don't know that. That is what we have to find. Next. Force applied on a second body. What we can assume? Force applied. It is the same, but we can assume as a F2. Is it yes or no, Hari? So F2 is equals to, what is the formula? M2 into A2. Okay. So that is what. What happened to Arun Kailash and Tanishkar? Did they not pick the phone? Arun Kailash call. So now if you'll notice it, M2 is equals to what, guys? What is the Vitakshri? M2 is equals to what? 4M and A2 only. So F2 is equals to what we will get, guys? 4M A2. What is that? 4M A2 newtons. Is it right or wrong? Everybody? 4M A2 newtons. Let me take this is equation number 2. What is this? Equation number what? 2. Now we know that they're mentioning in the question. What they mentioned in the question, everybody? Same force is applied. So same force is applied means F1 is equals to F2 is equals to what? F. Yes or no, guys? Please respond. Everybody. So I can modify first equation. F1 is equals to F is equals to, first equation is what? 18M newtons. This is the equation 1. Second equation, F2 is equals to F is equals to, how much it is? 4MA2 newtons. This is the equation number 2. Till here, any doubt, anybody can ask. Are you clear, everybody? Yes, please.
Yes, sir. Yes, sir.
Divide equation 1 with the 2. What will happen? Divide equation 1 with the 2. Everybody do the division and tell me. So what is the division will come? Observe very carefully.
9 by 2.
F by F. F by F is equals to equation 1. 18M divided by 4MA2. So this is what the equation. Is it right or wrong? Everyone? Yes. Now, F and F will get cancelled. We are getting what? How much? F and F will get cancelled. 1. Yes. Now, M and M will get cancelled. Now, observe very carefully so that what we is to get. Now, also you want to get cancelled. 4 ones are 4. Which table 18? 4?
Not come, sir.
Not will come. So let it be. So I will take it as a like this. So now the 1 is equals to 18 divided by 4A2. Now 4A2 will come this side. What will become? 4A2 will become this side, multiplication. So 1 into 4A2 is equals to 18. Now A2 is equals to what? A2 is equals to 18 divided by 4. So 4 4 is how much? 16. 2 point, you can keep 0. 4 5 is how much? 20. Which is equals to acceleration of second body, which is equals to how much, guys? 4.5 meter per second square. Because same force is applied. Yes or no? Yes. So that's all. So that is what the acceleration of second body. All of you write it. Have you understand, Mitakshri? Yes. Arun Kailas, you must be beginning. You should not join. Every day we cannot call you. Why are you making that to call every day? You cannot join in first. Write it. So this is what the homework sum. Have you understand now, Gokul, Kaushik, Akilan?
Yes, sir.
Yes.
Yes, sir.
Neatly solve neatly. Very, very important sum. See why I am taking here instead of 3 kg. Why can't I take 3 kg? But it is given in what? Not direct mass. They have given in what? Ratio. So you should not take 3 kg. Understand, Hari? If you solve that method also, it is wrong only, Hari. Okay, Hari?
Yes, sir.
If you consider as a 3 kg, it is wrong only because ratio they have given. Okay, that is why we should not do like that. So I am assuming as a what? 3m. And here it is given 4. So that 4m kg I am assuming. Is it any doubt? Anyone can ask. Are you clear? So this is what the first homework sum. So the homework sum which I have given in the yesterday's class. Everybody solve it neatly. Shall we start next question?
Yes, sir.
Yes.
Now let them finish. Once you finish this question, only tell me. Then only I'll move to the next question. Use mind. Simply don't follow me or something. You have to solve. See how your friends are solving, how you are solving. Observe everybody. Kaushik and Arun Kailas will never open the mouth and simply sitting in the meeting. That is what. So how your friends are solving? Same way you have to try. Gokul, you are saying half question you solved. What is the use of solving half question? You cannot solve full question. Right, next question, everyone. Mitaksri, yesterday's questions have you finished everything? Any doubt?
No, sir.
Okay, right, next question. A motor car running at the rate of a motor car running at the rate of a motor car running at the rate of 7 meter per second can be stopped by the brakes in 10 meters. Can be stopped 7 meter per second. Can be stopped by the brakes in 10 meters. By the brakes in 10 meters. So you can see, guys, he is not mentioned time, but they have given what? Distance, and what is the initial velocity? Anybody? What is the initial velocity? 7 meter per second. And it is stopped. Stopped means what is the final velocity, Hari?
Zero.
Per second. That is what you should understand from the question. And you can see they are asking what? Right. 10 meters. Prove that the total resistance to the motion. Prove that. It's a very proved question. Very, very important questions. Prove that. Different questions, very important. Prove that the total resistance to the motion. Prove that the total resistance. The total resistance to the motion. The total resistance to the motion when the brakes are on. When the brakes are on means what? Applied. Understanding? When the brakes are on, ready? Are you understanding? On is 1/4 of the weight of the car. Is 1/4 of the weight of the car. So we have to prove that. Answer also they have given. Have you noticed it, Hari? Read the question. So they are saying that a motor car running at the rate of 7 meter per second is stopped by applying brakes in 10 meters. Now we have to prove that. What we have to prove here? Everybody, prove that the total resistance means what? Applied force. Do you understand, everyone? Please respond. Total resistance to the motion when the brakes are on means applied is 1/4 of the weight of the car. That is what we have to prove it. Shall we start proving now? Everyone?
Yes, sir.
Yeah. Now observe very carefully. First of all, tell me what is the given data in the question. Everyone, what is the given data in the question? Initial velocity is equals to given. Initial velocity of the car is equals to how much? 7 meter per second.
7 meter per second.
Now, next one. Final velocity of the car. It came to stopped. So what is the final velocity? 0 meter per second. Okay. Stopped. Next. What is the distance traveled by a body? What is the distance traveled by a body? Distance is equals to 10 meters.
10
Now,
meter.
observe very carefully. They are asking what is the resistance. Resistance means what, Vartini? Mitakshri? Resistance means force only. Yes or no? Applied force. Yes. So if you want to find the force, we need two things. Anybody can tell what is the force means? Force means what? Mass in
M into A.
acceleration. Okay. So is it they have given the car mass? Anybody? Is it they have given the car mass? No. Yes or no? So now we don't know something. What will assume, Hari? Let the mass of the car is. Let mass of the car is capital M. Any doubt? Anyone? Any problem? Any doubt?
Yes, sir.
No. Now observe very carefully. So now we can find the force of the car. So force is equals to mass into acceleration. Mass is equals to what? Mass of the car. And you can find the acceleration, guys. From this data, we can find the acceleration. Which equation? Let me see who will say. Initial velocity, final velocity, and distance. And you can find the acceleration. Which equation? Which equation? V square minus U square is equals to 2AS. Okay, so that is what. So we can find the acceleration A is equals to V square minus U square divided by 2S, which is equals to final velocity is 0 minus initial velocity is 7 divided by 2 into 10. Nobody is answering. So 7 square correct. So 7 square means what? It is 49 divided by 20. So all of you do that and tell me acceleration is equals to, of course, it is negative acceleration because it is retardation. So what is the acceleration? 49 by 20, which is equals to everybody 2.45 meter per second square. What is the unit of acceleration, Gokul?
Meter per second.
Meter per second.
Second square, sir.
Be careful. But it is negative acceleration. So negative acceleration, what we used to call already?
Minus.
Retardation. Okay, retardation. But we are representing retardation only for minus. So that is why we are not taking. So that is what we can say. So what is the force of the car? M into 2.45. So which is equals to what is the total force? Everybody. Total force is equals to what? M 2.45 kilogram meter per second square, which is equals to what? M into 2.45 newtons. Is it right or wrong, everyone? Yes, please.
Yes, sir.
That is what.
Yes.
Now, observe very carefully. Now, as we know that, basically here if you'll observe, they are asking us what? When the brakes are on, then the force is 1/4 of the weight of the car. Is it yes or no? 1/4 of the weight of the car. Yes, please respond. Is it right or wrong?
Yes, sir.
Yes, sir.
Brakes is applied. What is the force we found? Brakes applied. What is the force we found? Brakes applied. What is the force we found? F is equals to 2.45 newtons. Now, when the car is moving, what is the force? Tell me. When the car is moving means no brakes applied. No brakes applied. So what is the force will come? Anybody can tell? F is equals to mass into original acceleration of the car. Is it yes or no, guys? Yes. So acceleration means in the case of, you can take A is equals to G. So what is the G value? They have not mentioned anything, but we have to. What is the G value? Anybody? 9.8 meter per second square. This is what the force. Remember, keep in mind, in question they have not mentioned anything regarding acceleration. Like this ratio questions will come. You have to take general acceleration of the car or acceleration due to gravity, which is equals to how much, Hari? Ready? Which is equals to 9.8. As we know, car mass is remains same, so that F is M into 9.8 newtons. Any doubt? Anybody? So now we want to find the ratio. So ratio of when the force is applied, brakes is applied, and when the car is moving normally. Understanding? Moving, which is equals to how much, guys? M into 2.45 divided by M into 9.8. So MM will get cancelled. So which is equals to, you can see, car moving, brakes applied and car moving ratio is, their mass is 1/4. That is what we have to find. So 2.45 divided by 9.8. Do it and tell me how many times it will come. 2.445, how many times 9.8? 2.45, how many times 9.8? Just check it, everybody.
0.
Hurry, how hurry? Times ratio. Let it be multiplied with 2.45 into 100. Okay, which is divided by 9.8 into 100. So which will turns into 245 divided by 980. Is it yes or no? So 245 ones are 2.5 fours are. So which is equals to what? What is that? 1 by. So now came or not? Yes, please. Answer came or not? That is what you have to prove it. Any doubt? So we have to prove that. So 1/4 of the weight of the car. So when the brakes is applied, what is the resistance force we applied? The resistance force we applied is 1/4 of the mass of the car. Okay. So this is how we have to prove it. Any doubt? Mitakshri, have you understand Mitakshri? Remember, when no acceleration is mentioned, we have to take acceleration of the car is how much? Generally 9.8 or else acceleration due to gravity. Both you have to consider same only. Is it okay, Ma?
Yes, sir.
Yeah, please make it. Is it completed? Everybody solve it neatly, slowly, please.
Yes, sir.
Like this. See, this is what the question's mind. We have to use the mind. Simply we cannot by heart or simply we cannot follow. Mr. Kaushik Ram, Kaushik, have you understand Kaushik? So how to solve? They are asking that the resistance means force. When we apply the brakes, what brakes are brake force we are applying? So that brake force must be 1/4 of the total weight of the car, they are saying. So that is why they are not mentioned the car weight, they are not mentioned what is the normal acceleration, etc. So simply they have given brakes is applied. So we assumed what is the car mass? What is the car mass? Capital M we assumed. And what is the acceleration of the car? 9.8 or acceleration due to gravity. And we have been compared and we have been done that. That's all. Is it okay, everybody? Yes, please. That is what you have to do it.
Yes, sir.
Everyone need to solve it. Everyone need to understand it and you have to make it. Clear, everyone? Shall we go to the next question?
Yes, sir.
Yes, sir.
If you have solved only, we will go. If not, it's not. You all solved? Right, next question. Mitakshri, Vartani, right, next question, everybody. Let me see this question. How will solve? Right. A bullet of mass 60 gram. A bullet of mass 60 gram. Try to solve, everybody. A bullet of mass 60 gram. Moving with a velocity of 500 meter per second. 60 gram. Moving with a velocity of 500 meter per second is brought to rest in 0.01 second. Is brought to rest in 0.01 second. So it's very, very fastly. It has been fast. It will exert more momentum or less momentum? Yes. More momentum. That is what very fraction of seconds have been found. Now find the impulse and the average force of blow. Find the impulse. Impulse means what? Force into time. Yes or no? Find the impulse. Everybody, impulse and the average force of blow. And the average force of blow. So now let me see who will solve it. I'm giving 2 minutes time. Let me at least find impulse, everyone. So you can find it first, initial velocity, final velocity, mass and all, they have given something. So from that you can find definitely something. So let me see who will say. What is impulse formula? Anyone? Impulse means what? Final velocity minus, final momentum minus. What nobody is saying. Impulse means momentum. That is what? Force into time. Yes or no? So force means we can find the change in momentum. So we can write that also. First, given mass of the bullet. How much? Mass of
60
bullet,
grams.
60 grams. Is it we can take 60 grams or we need to convert it into kilogram?
You have to convert it to kilograms, sir.
Kilogram. So 60 into 1 by 1000 kilogram. Everybody, how much it is? Tell me. Which is equals to mass. 0.
0.
Yes.
0.06, sir.
0.06 kilogram. Is it right or wrong? Mass. Next. Initial velocity, how much? Initial velocity 500 meter per second. Final velocity 0 meter per second. Why final velocity 0 meter per second? Because it brought to what? It brought to what? Brought rest. In how much time? In how much time? Time
0.01 second.
0.01 second. Now observe very carefully. From this we can find something. That is what? Now we know the initial momentum, we know the final momentum, and we can find the impulse. Now what is the impulse formula? Everyone, impulse I can represent with what letter? Hari? Ready? Impulse I can represent with I, which is equals to final momentum minus initial momentum. What is that? Minus initial. Okay, so final momentum means what? Final momentum m into v minus initial momentum m into u. So which is equals to impulse. So impulse I is equals to m is common, v minus u. Substitute it and tell me how much. Impulse.
30, sir.
Yes.
30, sir. 30.
Mass is equals to how much? 0.06 kilogram into velocity 0 minus 500 meter per second. So which is equals to 0.06 kilogram. Understanding? So next this will become what? Into minus 500 meter per second. So if we'll do this one, we'll get 500 into 0.06. How much are today? Yeah, minus 30. Minus 30 kilogram meter per second. Okay, but you can see kilogram meter per second, we can write something. What is that? Kilogram meter per second. Anyone?
Newton.
No, you cannot write Newton. Observe very carefully, Hari. Kilogram meter per second square is Newton. Do you understand, everyone? Do you understand or not?
Yes, sir.
Yes, but here what we have? We have only what?
Velocity.
Kilogram meter per second we have. Understand, Ra? Yes, please.
Yes, sir.
Yeah. Now I want to make it into Newton. Mathematics rule I can apply. What I can do, Reddy? Tell me. Numerator and denominator, can I multiply with a second? Is it right or wrong? Everybody, Vartini, Mitakshi, can I multiply numerator and denominator with a second time?
Yes, sir.
Then what will it turn? Kilogram meter per second into second, second square into second. Is it right or wrong, Hari?
Yes, sir.
Now kilogram meter per second square, how I can write? Newton and into second. Can I write it or not? So I can say impulse is equals to minus 30 Newton into second. Is it right or wrong?
Right, sir.
Right or wrong? Because why means, what is the impulse means? Force into time. Yes or no? Force into time. Is it right or wrong? Yes. So what is the unit of force? Force is Newton, time is second. So that is what it is. So I written like this. Any doubt?
No, sir.
That's all. So now you know that if F is the average force blown, then as we know, I is equals to Ft. Is it yes or no, guys? I is equals to what? Ft. Is it okay, guys? So this is the formula. So we know I is equals to F into time. Now F, imagine F is equals to average force. What is that? Average force blown. Now we want to calculate the force. So from this formula, force is equals to, what is the formula? Tell me. Force is equals to impulse divided by time period. Now impulse how much, Hari? Impulse how
30, sir.
minus 30
30.
Newton second divided by time how much? 0.01 second. So second will get cancelled. So all of you do it. What is the force equals to how much? Tell me. Answer I want. Minus 30 newtons divided by 0.01. So I can multiply with what? 100. Understanding? Divided by, sorry,
Minus 3.
0.01 into 100 newtons. So how much it will come? Everybody. Mitaksri, what happened? No response.
Minus 3,000.
Yeah.
Minus 3.
Minus 3000 divided by 1. So newtons, which is equals to what is the force? Average force blown. 3000 newtons. Okay. That is the answer. Is it okay, everybody? Yes. 3000 newtons
Yes.
also. Can I write it as a 3K newtons? Can I say or not? K means 1000. Yes or no? So 3000 newtons, I can convert into 3000 into 1 by 1000. Understanding? So K means that is what. So 1 by 1000 will get cancelled. So which is equals to 3 kilonewtons will get it. Okay, everyone? Or else we can say 3 into 1000. So 1000 means what, Hari? 1K. Okay, everyone? So K we can write it. That is what you can remember. So I can write 3K newtons or 3000 newtons. Whatever you are convenient, you can write. So this is what about this sum. Any doubt? Anybody can ask. Are you understand, everyone? See, smartness. Based upon the situation, we have to turn it. Now here, momentum means we cannot get the impulse unit. Yes or no, Hari? Ready? Gokul, if you take momentum, change in momentum,
Yes, sir.
we won't get the unit of impulse. Unit of impulse what? Newton into second should come. So I modified both numerator and denominator. I applied with the second and second. I modified as a Newton second. Right or wrong?
Yes, sir.
Okay, everybody saw. How is the question ready? Very smart question, yes?
Yes, sir.
We have to use the brain always. That is what I always will say. So if you are not enough smart, we are not going to be doing anything more. So that is why be very smart always, kindly, so that we can do the things very carefully. Clear, everyone?
Yes, sir.
Okay. Any doubt, anybody can ask. Right, everyone? Right, next question. Solve it slowly. I'm displaying slowly. Solve those who don't know. Arun Kailash, have you understand? At least say yes or no, boy.
Yes, sir.
Write it. Simply you are saying yes, but you are not all studying. I will say I will speak evening. I will speak with you. You are not all studying. I came to know. I will say do it fast. Next. Akilan, have you understand, Akilan?
Yes, sir.
This also unit conversion also please note it down because if people don't know again your people will get confused. Today you can, but later you cannot understand. That is why slowly you can do and you have to make it. Next, force. Have you found force?
Yes, sir.
Yes, next. The meeting is going to end, join back. I'll give the question also. Write the question now. So everybody need to know all the things, all the formulas and all. So I'll give you one flow chart also. So that flow chart you can remember. I will send you in a group. That flow chart will give you all the formulas and all the things when the bodies are acting and all. So everybody should learn that and we have to solve that one based upon that only. Okay. So meeting is going to end. Come back and we'll start doing the things. Right. It's all that question everybody.